Hello and welcome back to day 4. I wasn't sure I was going to do this day because I thought I was having difficulty figuring out a way to TDD it, but slept on it, came up with an idea, and here we are. So let's dive in. Day 4. Looks like the chief's not here. One of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the monitoring station. As the search for the chief continues, a small elf who lives on the station tugs at your shirt. She'd like to know if you could help her with her word search. She only has to find Xmas. It can be horizontal, vertical, diagonal, backwards, or even overlapping. A little unusual though, as you don't merely need to find one, you need to find them all. So this is our input, right? We're going to need to count the number of times Xmas shows up. They give us this helpful version with all the letters removed that don't matter, right? And tell us that it'll be in there 18 times. Okay, so let's go over here and let's take a look at what we should be doing here. So this is a classic kind of advent of code problem, setting up a data grid and doing some kind of a search. So they're giving us an easy one to get started. So here we go. Let's do a grid, right? And then we're going to do grid tests. So how would we like to use this grid? Public void, no matches. All right, let's do our grid is a new grid with empty string to start with, and then we're going to say var result is grid count Xmas. All right, and then assert equal 0 results. Okay, so what do we need to make this work? Obviously, we need a constructor. Call this lines. That's really what it's going to be, is all the lines of data. For now, that doesn't need to do anything, and then we need count Xmas, which for now can return 0. And that'll be fine. Okay, we'll get this to run. All right, let's immediately turn this into a theory. Inline data for the board. All right, string, well, the lines, right? That's what we called it, is the lines. Okay. It still pass. Yeah, let's put some other things in here like XMA and I don't know. AMX, right? Those are not Xmas. Okay, so there's a few pieces of data now to give our no match test some meat. All right, let's go with one match. And actually, we already know we're going to do this as a theory, right? So let's go ahead and do that. Inline data, Xmas. Okay, so given these lines, we want to do the same thing, except we want to get one result. This is obviously going to fail because we haven't actually implemented the search yet. So what does our search look like? Well, we have a grid, right? So we're going to have to convert our lines into their grid. And the easiest way to do that is as a double character array, right? So we use a 2-dimensional array, which will go, we'll do one line at a time. That's the first index. And then, you know, the character in there will be the next index. So it'll actually be like a YX instead of an XY. That's the way it's going to be easiest to come out, right? So grid is going to be lines split. We're going to split on new lines, new line characters, and then we're going to use string split options, remove the empty entries, and then we're going to turn that into an array, except we need each line to be to a character array first. So that's all like that. That's a long line. When I see things like that, I like to do this and line things up on the dots so we can see exactly what's going on here a little bit better. All right, so that's our grid. So our count obviously is going to have to now look at the grid and try and find Xmas. Okay, so we'll start with, let's see. So we said it's going to be rows first, right? So for row, it's going to be less than grid length, double plus row. And then column, oops, this is supposed to be row less than. This is supposed to be column now less than grid 0 length. So we're going to make an assumption here with this that it is a grid that has the same number of elements. Actually, we don't even have to do that, do we? Because we can do this grid sub row. Never mind. I'm just going to do a shortcut that we absolutely have no reason to do. Okay, so here we are. We're going to loop through this rows and columns. We're going to say, the first thing we're going to say is if the grid at the row and the column is not equal to X, we don't care, keep looking, right? And then given the data that we have here, we really only need to look to the right to start. So let's do that first, right? So if grid row column plus 1 is equal to M, and grid row column plus 2 is equal to A, and grid row column plus 3 is equal to S, then we found an Xmas, and then we keep going. Okay, so what happens when we run these now? Okay, well, these both failed because we got index outside the bounds of the array, right? So we found an X here and we found an X here. And in both cases, we're going to run off the array going to look to the right. So I was sneaky when I put that data in there because I knew that that was going to happen. So what I want to do here is instead of doing grid row of column, what I want to do is I want to extract that into a method which is char at. Okay, that's what we'll do. We'll have it called char at. I'm going to go ahead and bring this up here as I am obsessive about wanting to alphabetize things for no good reason. So this now, and we should have done this with this. So char at row and column plus 1. We can centralize all of our need to bounds check the array into this one function. So we could return pretty much anything that's not an X, M, A, or S when we're out of bounds. Personally, in scenarios like this, I like to say this is going to be nullable, and I'm going to instead return a null char. Because then it's, well, I don't care what the special chars are, null is not a char, right? So here we're going to say if row is less than 0 or row is greater than or equal to grid length, and we're going to return null. And then we're going to say if column is less than 0 or column is greater than or equal to grid row length, we're also going to return null. Otherwise, we can return what's sitting on the grid. Okay, so now our test should pass because instead of running over the end of the array and causing a failure, we're just returning nulls as the thing goes out and looks for Xmas off to the right. Okay, so now what happens if I need to do SAMX, right? That is also a legitimate version. So now that data is not going to pass. We also need to look left. I'm going to write this one more time, just so we can see the commonality here and make this pass. But you can foresee what's going to happen here, right? We need to look in every direction. And I could duplicate this code over and over again, or I could use something that allows me to run in specific directions. So let's put the next piece of data in here. Let's do this. So we're going to do this XMAS, right? That should do it. And this is a multi-line string. If you've never seen one of these, this is a triple quote string. So this is just going to give us XMAS with nothing else. All right, so that's going to fail because we're not looking down. And now when we got to look down, I start to think about, well, what are all the ways we need to look? And the answer to this is going to be something like list of dx, dy. If you're not a math person, d means delta. So delta x and delta y. What are all the directions we can go? Okay, so we'll do this. Let's take a look at all the directions we could go. So we could go, let's do right, and let's do left. All right, so for now, those are the two directions we have. Let's rewrite this to get rid of the commonality. All right, so for each var dx dy in directions. Okay, this is called, I can't remember if we talked about this before, but what you can do here is you can deconstruct the variable. So instead of saying, I'm pretty sure we talked about this, direction dx and direction dy, I can just say, I really want the deconstructed values directly. Direction as a container doesn't really help me at all. Okay, so we can use then this loop, right? And we'll say, instead of dx dy, what should we call these? We should call these, delta row and delta column. Back up, delta column instead of x and y. So this is going to be delta row and delta column. So row plus delta row, column plus delta column. So that's going in one step, right? So the next step then is 2 times delta row and 2 times delta column. And this line is getting pretty long, so we're going to go ahead and wrap this. And then row plus 3 times delta row and row plus 3 times delta column. Okay. So I like to indent this just because then this makes it look a little nicer. That should still find our xmiss and our samx. It's not going to find this because we don't have this direction in there yet, but I want to make sure that we didn't break anything. We're going to go ahead and do that. Okay, so our xmiss going down is not helping. So we can add these one at a time if we'd like. What I like to do here is I would like to just go ahead and put these in. We have -1 and a -1. Actually, let's do this. All right. So I like having them line up like this. -1, -1, -1, 0, -1, and 1. Then we've got 1 and -1. And we've got 1 and 0. And we've got 1 and 1. So what we're missing here is we don't have 0 and 0. And obviously the reason we don't have 0 and 0 is that leaves us in the same place every time. We already know that the x is never going to change from being an x. So it's not going to go x and as all in the same spot. So that's not possible. So those are our directions, right? So now if we run this, our xmiss going down is going to work. Right, and so we can put in some more interesting ones just to make sure that we've got this covered, right? So we can do an X, an M, A, and an S, right? We can do S, A, M, X, right? There's a couple more, so close off your inline data there, buddy. So we can do all of the data items here. Let's take it for granted that we did all the data items here. We really should, but I just want to move on for time. So there's one match. Now what happens when we want to say 2 matches? All right, it's going to be another theory. And we're going to do this. So we've been given some instructions here about not only can they go in any direction, but they can overlap with other words, right? So we've got, for example, we'll pull a few examples here, right? So one example will be, let's see, SAMXMAS, right? That should get us 2, right? Because we have Xmas going that way and Xmas going that way. Okay, so did we get 2 here? We only got 1. Okay, that's interesting. I would have expected us to actually get 2. XMAS, XMAS. Okay, well, let's see. Let's step in here and see what's going on. Okay, so for starters, we're going to look at the grid because that's useful, right? SAMX Xmas. Okay. We are currently at row and column. We're going to want D row and D column when they're available. Roll this up a little bit. And then we're going to want char at. Yeah, that's okay. We can figure it out just by looking at it. Okay, so we're in column 3. That makes sense, right? That's the X. Okay, so what's our first direction? Our first direction is -1, -1. So that's going to fail because that's going up that way, right? So that's going to fail. And then our next direction is going to be row and column. So that's going to go down. Actually, that's going to go up. So that's not going to work. And then we've got -1, 1. That's going to go this way. All right, so we're still looking for right and left here. So here's left, right? Same row, negative column. So if I do char at 3, sorry, the row is 0, 3, 0, 3. That's our X, right? And we do 2 and 1 and 0. So that one should work, right? XMAS. So that gets in there. Okay. Now we're doing right. So if I look at 4, 5, and 6, that should be in there. It is. You know what? I bet the test is wrong. It is. Okay, well, that's why I was failing, because the test was wrong. That happens sometimes. All right, so we found our Xmas. We can do some other crazy things like X, M, A, S, X. Nope. X would have to be down here, right? X, M, A, S, right? That should get us 2. So that's not bad. So that gets us 2. All right, I'm feeling pretty confident. We could throw a lot more test data in there, and in a real world situation, we would throw more test data in there. But for now, I'm feeling pretty confident about that. So results, what we need is a grid, right? So we need a grid, and it wants the lines. So let's do file, read all text. We've been doing read all lines, which breaks up the lines, but we're going to do just text this time because I wanted to make our data easier than having multiple arrays, right? And then the result is going to be grid.countXmas. Okay, do we get 18 like we expect we should? Let's find out. We do. Okay, so we have our big set of data, which looks roughly like this. It is gigantic, right? So if we look at columns, this is about 140, right, by 140. So it is a big giant square. And if you look down the sides, like it is actually square. But that's just something you're going to have to keep in mind that might not always be the case. Now, because it is before, right? I know that my answer is 2567. So does our code actually give us 2567? Let's see. It does. Okay, so we're halfway done. Let's read the next half of the problem. Okay, part 2, the elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find you're not actually searching for Xmas, you're searching for X-mass, which means you're supposed to find 2 mass in the shape of an X. One way to achieve that is like this. Relevant characters have again been replaced. Okay, so within the X, each mass can be written forwards or backwards. All right, well, let's start with this data, right? We like this data. So these are, I'm going to put these in a subclass because these are tests for find Xmas or count Xmas. That's what we called it, count Xmas. Okay. So that's those tests. I'm going to make a new class because we're going to make a new function, right? We're going to call this find crossmas. That's the best I can come up with. All right, so theory. Inline data. All right, we're going to take this as our data. All right, so public void 2 matches. That's a good place for us to start. We have this, except we're going to count crossmas, not find crossmas, count crossmas. Okay. So we also need to count crossmas. For now, let's return 0. And actually, this really shouldn't be our first test, right? Our first test should be exactly like this first test. So let's steal this first test. Put some things in here that don't match up. Mass. And that's good enough for now. We'll come up with some other ones that are weirder in a second. Okay, those are going to pass because, of course, we are returning 0 by default already. But now when we come down here and we look at this puzzle, we can make this work. So one of the things we could do is count, let's call this count matches. Expected matches. So now we can say these are expecting 0, right? So there's another way that we can sort of combine all this data up. Let's get this up here, because we know this is expecting to return 2, right? And now when we run this, that's going to fail because we're hard returning 0. So now we need to find mass that looks like this. Let's reread the rules again. Relevant characters, yeah, okay, so here's a sample. Within the X, each mass can be written forward or backwards. So what exactly does that mean? Can be written forward or backwards. Means that we have Sam and Sam, right? So that's one that is 2, right? And then we've got Mass and Sam. All right, so you can see I'm putting the M's all along one side here, so we need M's on the right. That'll be the 4 different ways that we can write this, where this comes out correct. Okay. So we know that those are going to be our 4 cases for 2. So all those are going to fail, right? Okay, 1, 2, 3, 4 failures. That looks good. So how do we find this? Well, this grid search looks a lot like the other grid search. Okay, so let's steal some code. Let's absolutely steal some code. Like var results, return results. Let's loop over and look for A, right? Because A is now the center of what we're looking for. So then once we found an A, this isn't going to be a search in a direction for MA and S, right? We're looking for MS, MS, right? So we need opposite corners to have an M and an S. We're going to want to try and check all of those corners. So, but basically we'll do one set of corners and another set of corners, right? And so we'll do if is M and S at row plus 1 column, and then let's see. Actually, let's do it like this. We'll do char at row plus 1 and column plus 1, char at row minus 1 and column minus 1, right? Because those are opposite corners for each other. And is M and S. Oops, need a closing parenthesis over here. And is M and S. The char at row plus 1, column minus 1, and char at row minus 1, column plus 1. So those are the other two corners. Okay, so if that is true, then we do our results. So we just need is M and S. Just going to return a bool. Right, so this is pretty easy. This is going to be V1 is equal to M and V2 is equal to S, or V1 is equal to S and V2 is equal to M, right? So that's pretty easy. That's going to check our corners, right? So now we got our two corners. So let's see what happens if we run this now. Feel like that's going to work, except it didn't. Okay, well then let's find out why it didn't. Okay, let's put a breakpoint there just to make sure that we're doing things interestingly. Okay, that's count matches. Oh, we're counting Xmas. That's why. Count crossmas. So there we go. Test wrong again. Let's see if that's going to work. 2 and 1 and 2 and 1. Well, that's interesting. Oh, no, that's right. That is only 1. Sorry, I don't know why I was thinking it was just 2. This is 1. Right? So these are our single crosses of mass, right? Let's go back and look at our interesting data, right? So we see a mass here, we see a mass here, MAS, MAS, SAM, SAM, that's another one, right? SAM, SAM, MAS, MAS. So you can see how they've got them overlapping. So another interesting set of data might be to just take this double cross. We'll make sure that the double cross is working correctly. A, S, M, right? So that's a double cross. So that should be 2 of them now, right? Okay. Well, there we go. That's also working. So I feel like I feel pretty good about this. Let's see if we're matching up with our number 9. We are not matching up with our number 9 because we did not call the stuff we needed to call. And this is count crossmas. Okay, so there's 9. Fingers crossed. Let's see if we get 2029 because let's double check. Yep, that was 2029. Okay, good. And then we run it again. And that's our answer. Okay, so that's it for today, right? That's we could obviously write a lot more tests here, but what's interesting is that in the past, when we've written tests for our production code, we've just pulled in the data directly from like data1.txt. And I feel like these tests are easier for us to read. So this made more sense to me to do this rather than to try and bring in more complicated data and then, make sure that we're doing everything in the right way. Let's take a quick peek up at grid and see if there's anything that we would want to do differently or anything that we might want to refactor. So we definitely have this and this are basically the same, right? You're looking for a letter at a specific location, and then what you decide to do with that letter is what changes, right? So how could we refactor that out? This is basically a find a letter. So if we were going to do that, we would have something kind of like int find letter. The letter, we need to know the letter, right? And then we need some kind of a function which takes which takes what? Takes the row and the column and tells us whether or not or how many results we have for that. All right. This will make more sense here in a sec. So this loop looks like this. Okay, so the result is going to start as 0. And then we're going to return the result. And we're going to say if we matched the letter, then result is going to be increased by the callback for this row and this column. Okay. Which means we can do this. Okay, so how would this look? Let's do count Xmas first, right? This is basically our callback. So what we're going to do is we're going to do find letter. I'm just going to go ahead and comment this out for a second because we're going to make a second copy here, right? So we're going to find letter X, right? And given letter X, given a row and a column, we need to, our result is 0. We're going to return this. And up here, we're going to have a result of 0. Right? We're going to have this code here. Right? Turn the results. So that's matching just one iteration of finding the letter X. Right? And then the rest of this can just be commented out for the moment. Let's run our tests and make sure our tests are still working. They are, so that's good. So that means I can just yank this code out of here. Right, and now what I want to do is I want to say, comment this code out. We're going to say return find letter. This time we're finding A. And given a row and a column, we're going to do this, which is this. Right, var result is 0. That. Actually, we don't even need to count because we don't have a loop here, right? You can just return 1, and then you can return 0. We don't even need a result variable here, right? Because we need a result here because of the loop. But we only have one possible hit. If you found an A, it either is or it isn't. Okay, let's make sure our tests still pass. They do. Okay, not bad, not bad, not bad. Let's delete all this code. Okay. So now we have this. I feel like this is pretty well optimized. Interestingly, like directions is a thing that only needs to exist in one place. Doesn't have to be out here, right? We could put directions in here for count Xmas. Right? And then same for is M&S. That could come in here as a local function. Right? Okay. And you're just telling me you could be static, right? Yep. Okay. Well, that looks pretty good. I'm happy with that. You know, we have our double loop here. We're using charat to isolate ourselves from running off the ends. So charat's used in both places. So that stays out there. But otherwise, we look pretty good. What are you trying to do? You're trying to tell me to make a primary constructor. Okay. I'm fine with that. I like primary constructors. That cleans that up a little bit. In case you haven't seen that syntax, this is a constructor now. It takes lines, and we can reference that lines anywhere we want. Here, we're referencing it during the constructor because this value gets set during the constructor. We could also reference it here. And then we would have access to it here if we needed it. It's probably going to tell us, I was going to say, that we don't need that variable, but okay. You're probably telling me you can be read-only. Sure. It sounds good. And I think that's all we needed. Right? We could have a bunch of test data down here if we really wanted to, but I think that's pretty much good to go. Okay, so given that, not too bad today. We learned sort of a new pattern here of there's going to be a problem in advent of code later on down the road. You're going to have to search for things. This grid, 140 by 140, not so big. Again, we're not running over sizes of ints. We're not running over gigabytes of memory. So far we're okay. But, it's only day 4. So anyway, I think that's going to be it for today, and we'll see you next time.